Hi guys, in this video we're going to talk about domain versus range and rate of change. Let's start with the definition of both the words domain and range. The domain of a function is the set of all possible x values, inputs, which will make the function work and will output real y values. The range of a function is all possible y values or outputs of a function that result when we substitute all the possible x values in the function. Okay, let's put these words in practice. Let's take a look at our first example. We have a relation set 2, 3, 3, 4, and 4, 5. If you look at this relation set, we have the inputs 2, 3, and 4. These inputs will make the domain of the relation set, which means the domain includes 2, 3, and 4. If we look at the outputs, we'll see that the outputs are 3, 4, and 5. That means the range of the function includes these outputs, 3, 4, and 5. Let's take a look at a second example, and this time we're looking at a map diagram. If you look at this map diagram, you'll see that the arrows are going from left to right. That means the left group includes the inputs and the right group includes the output. So the domain in this case is going to include 7, 8, and 9, and the range is going to include 7 and 8. Now, let's take a look at another example where we have a graph. In the graph, we have to think about the x values that make the function work. And for the range, we have to look at the y values that result when we use these x values. And to identify the domain for a function represented in a graph, I'm going to use a vertical line. And imagine that this vertical line is going through the x-axis and identify the values, the x values that belong to the graph. So let's start. I'm going to imagine this vertical line going through the graph, and we'll see that the graph or the vertical line starts at this value right here. This is the first value that we can see on the graph when the vertical line is used. And then this means that the x values that belong to this graph is every single x value greater than 0, because these values are the values that has outputs on the graph. So the domain in this case is going to be every single x greater or equal to 0. Now for the range, I'm going to have to do the opposite. I'm going to imagine a horizontal line going through the graph, and then look at the y values that results from the graph. So I'm going to imagine that this horizontal line is going through the graph from the bottom to the top. And we'll see that this line crosses the graph from the bottom values to the top values. That means that the range for this function includes all the real numbers on the y-axis. All the numbers on the y-axis, because as you can see here, the graph doesn't end, which means that I'm going to have to include all the y values on the y-axis. So the range is y equal r, and r represent real numbers. Now, let's take a look at a table. We have this example where we have time and temperature. time in this case is going to represent the independent variable, which is x, and the temperature is going to represent the dependent variable, which is going to be represented by f of x. So in this case, we know that the time is continuous, and I'm looking at the table and I see values going from 0 to 8. So I know that my domain is going to include every single x that is equal, greater or equal to 0, and less than or equal to 3. At the same time, I'm looking at the range and I see just one value, which is 5. So the range is, in this case, is going to be y equals 5. We talked about the rate of change when we talked about linear equations. But now we're going to talk about the average rate of change because we are working with nonlinear graphs now. So we know from the past that the rate of change is equal to the slope, and it's the difference in the y over the difference in the x. And in this case, since we're talking about functions, we're going to talk about the rate of change, or the average rate of change, which is equal to the difference in f of x divided by the difference in x. Let's find the average rate of change for a function over an interval. And this interval that we're looking at on this graph is going to be for every single x greater or equal to -3, less than or equal to 0. So my focus should be on every single x on the x-axis that starts with -3 right here and ends at 0, including -3 and 0. And to find the average rate of change, we said it's the same as finding the slope, the difference in f of x, which is instead of the difference in y, over the difference in the x. So looking at this graph, I can use the raise overrun to be able to find the average rate of change. And in this case, the rise is going to be 3 units up, and the run is going to be 3 units to the right. That means that the rate of change, or the average rate of change, is going to be 3 over 3, which is equal to 1. Now let's find the average rate of change for a function over an interval represented by a table. And the interval is going to be every single x is greater or equal to 2, less than or equal to 4. So let's identify this interval in the table. I'm going to start with x equal 2, including 2, and ends at x equals 4, including 4. So I know that the average rate of change is the difference in f of x over the difference in x. I know that y represents f of x. So the difference in f of x is going to be the difference in the y. So I'm going to have to subtract 4 from 16, and 16 minus 4 is 12. And the difference in the x, I'm going to have to subtract 2 from 4. 4 minus 2 equals 2. So now the rate of change is going to be 12 divided by 2, which is going to be